Hi everybody. We are working in Quest Math today on finding area. So last week you were working on perimeter and we're going to kind of make that review perimeter a little bit today, and then we're going to move into area. But before we start doing that, I want to connect this to something you already know. And to do that, we're going to talk a little bit about arrays. So let's start with something easy, okay? A math fact. I know you guys all know how to find what is the answer to 3 times 5. But we're going to use an easy one so that you can understand the concept that we're going to be working on with area today. So if I were to put 3 times 5 into an array, I would be doing 3 groups of 5, right? So I would have one group of 5. I would have 2 groups of 5, and then I would have 3 groups of 5. Okay, so this picture is an array that shows me what 3 groups of 5 would look like. 3 times 5, and of course we could finish that number model. We could say 3 times 5 is 5, 10, 15. We would know that it's 15, okay? But what I want to work with today is this shape that we made in the array. We made a rectangle, right? If I were to box this in, I could see very clearly that I have made the shape of a rectangle. Well, last week you worked on knowing what the perimeter would be. So you worked on formulas, P for perimeter, and you were finding ways that you could describe this line all the way around. And actually, I can make this note for us. I like to remember perimeter has the word rim in it. And if you know that the rim is an outside edge, like maybe the rim of your glass or your cup, the rim is the outside edge, so the perimeter is measuring all the way around. So last week you looked at that by a special formula. You knew that this side was 5 across, 1, 2, 3, 4, 5. This side was 3 across, 1, 2, 3. So you knew you'd have 2 groups of 3, you'd have 2 groups of 5. This side and this side, 1, 2. This side and this side, 1, 2. And so we worked on a formula that was 2 sets of the length, and we use an L like that so it doesn't look like a number 1, right? So we have 2 sets of the length, a 5 and a 5, and we added that to 2 sets of the width, in this case 3 and 3, and we were able to get the perimeter. So there was a couple of different ways you could do that, of course, in your head, and whichever way of doubling you liked better. You could do side and side. 5 and 5 is 10. 3 and 3 is 6. So if you put that together, in this case, the perimeter of our rectangle is 16. But we can also talk about this shape as in the area. And when I say area, I'm talking about how much space is inside. So the perimeter was the outside, the area is on the inside, okay? How much space is in here? Well, I drew my array to help us see that. If I were to say how many X's or how many pieces of space are there inside this rectangle, you could count every single X, right? You could count 1, 2, 3, 4, 5, but there's an easier way to do it, isn't there? If we want to find the area, we could think of it like a multiplication problem. We could, and actually I can put it right here, we could say the length of this rectangle, and again we use a cursive L so it doesn't look like the number 1, times the width of my rectangle gives me the space inside. Do you see how that's the same as an array? When I multiply the length times the width, in this case I'm doing 3 times 5, that's the same as my array. It's the amount of space that it takes up inside. 3 rows of 5, 1, 2, 3, 5, 10, 15. So the area of this shape is 15, and I didn't give us any units, so we could just say units, but I'm going to add this little 2 up here. When I do this little 2 up there, it means squared. It means I have 15 square units. So if I thought of this like maybe a graph paper, and each one of these rectangles took up 1 square space, I'm saying it would take 15 of these pieces to fill up this shape. They could be inches, they could be centimeters, they could be feet, they could be miles, whatever we're measuring, whatever it makes sense size-wise. In this case, I don't know, so I'm just calling it units. We always want to have a label there. So it would take me 15 square units to fill up this piece. So today, you are going to be working with area. So let me give us a little more space. And we'll get rid of perimeter since that was last week. So if we think about area like arrays, let's say I have a shape that looks like this. And I am telling you that it is, let's say, 12 inches across the bottom, and it's 2 inches across the height, or the width in this case, since it's a flat shape. And we want to know how much space is on the inside. If you picture it like an array, if you picture it being, this is 12 inches this way, and we have 2 groups of them, I can picture that just like an array. I can think 6, I'm making this into 12s. So now I have 2 rows, see it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 2 groups of 12. So if I multiply 12 times 2, I come up with 12 times 2, do you know it? Say it. Hopefully you said 24, okay? It would take 24 of these, they're supposed to be squares to fill up this rectangle. So I'm going to put my label on there, 24 inches squared. I'm talking about the space inside. I'm not talking about just a straight line. So I want to make sure I know that they are square units, okay? So in your lesson today, you are going to be practicing area. You're going to be given some shapes like this, and you'll have to just multiply. Length times width equals area.